In this lesson, we're going to look at measures of center again, but specifically we want to see how does the position of the mean and median compare depending on the shape of your distribution. And we're going to do that by creating several histograms and analyzing what we see. So you can think of the mean as a balancing point in a histogram. If you were to put it on a scale, right at the mean, it would be perfectly balanced. So what you're going to do now is you're going to make 3 different histograms. I'm going to guide you through the first one. The other 2 you can construct on your own. Okay, so first of all, you need to decide your bin size. So each of the bars are often referred to as bins. In this particular example, the bin size has been given to you. So there are some things that you always want to do in every single graph that you make to be successful in STAT. Borrowed this from Mr. Youngsaber from Skew the Script. He says, always give a title, tick, tick, label, 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 meaning make sure your data or your graph has a title. You're putting tick marks to scale both the X and the Y axis, and you're having labels on both your X and your Y axis and any potential key that you would need. Now, you will often see people make a frequency table to construct a histogram. So the intervals are here on the left and the counts are here on the right. Frequency, now this one is already in order from least to greatest, which may make it unnecessary to do this step, but I do want you to see it at least one time. So 3 tick marks, you might see a numeric character, doesn't really matter. I see 4 8s. Between 11 and 15, there's 1, 2, 3, 4, 5, 6 values, 4, 5, and 6. Between 16 and 20, I see 4 18s, and between 21 and 25, there are 3. Okay, so now you're going to construct each bin. So 1 to 5 has a height of 3. 6 to 10 has a height of 4. So things that you want to do when you're making this by hand is make sure that there is no space between the bars. Additionally, you want to do your best to make your bins be equal in width, because otherwise you would be violating the area principle and cause your graph to be misleading. And 21 to 25 has a height of 3. Now, typically you would have a label on every axis, and if this data had some meaning to it, there would be a title on the top to put it into context. The other thing I want to point out is you may have read about a relative frequency histogram where these counts, which are the frequencies, are changed into proportions or percentages. So this would be 3 out of the total converted to a percent. You will see some like that from time to time. So what I would like you to do is pause the video and construct the next 2 histograms on your guided notes, and then you can of course hit play to compare the histograms. So here's what my second histogram looks like. And here is my third. Again, I didn't do a great job with titles and labels here. You'll do much better when I give you one in context, for sure. Okay, so now what we're going to do is describe the shape and calculate the mean and the median for all 3. So to describe the shape of the first distribution, I would say if you kind of drew a smooth curve kind of over top of this, to me this looks symmetric. Additionally, how many peaks does it have? I would say just 1. So this is symmetric and unimodal, meaning it has 1 mode. Let's calculate the mean. You're actually given the raw data, so find the sum and divide by the number of data items. The mean is 13. For the median, there are 20 numbers. So here is the 10th and the 11th number, so halfway between, or the average of the 2 middle, would just be 13. Halfway between 13 and 13 is 13. Okay, so notice that the mean and the median are equivalent in this histogram. For our next set of data, how would you describe the distribution? Well, if you kind of imagine it like this with a curve, I would say that this one is skewed to the right. Okay, so the tail is going off this direction, so skewed right. Again, calculate the mean and the median. Pause and check your answer. So the mean is 9.75 and the median is 8. So notice that the mean this time is greater than the median, or in other words, it's kind of being pulled in the direction of your data. If it is skewed right, the mean is pulled to the right. When we look at the third histogram, to describe the shape, this one, I would say, is skewed to the left. The tail definitely moves to the left on this one. You could also say that it is also unimodal, meaning one peak. Okay, so again, calculate the mean and the median, pause and compare your answer. So my mean is 16.25 and the median in the middle I get 18. So notice what's happening this time. So this one's skewed left and the mean again is being pulled to the left in the direction of the data. Okay, so let's generalize. So how do the mean and the median compare? Well, if we have symmetric data, we saw that they're equal. However, if it is right skewed, okay, so in this one, which one was greater? Well, the mean is pulled to the right, so the mean is greater, or we'd say the median is less than the mean here. Whereas if it is left skewed, the mean again is pulled in the direction of that, so the median is the larger this time. So I just always remember that the mean is going to be pulled in the direction of any outlying values or any skewness. One last concept I want to just demonstrate here is how do you determine the median if you're given a histogram? This typically pops up in some form on the AP exam. Now, you would not be able to find the exact mean in this particular data here. So we would find the median, and the reason you couldn't find the mean is you're not given the raw data here. The only thing you can see are your intervals. So what I would start by doing is just labeling my frequencies. So 2, 3, 5, 7, 9, 9, 8, 7, and 5. And then I would determine my total sample size by finding the sum of those bins. And I get a sample size of 55. Okay, so I know that this was made out of 55 students who took the ACT rather than the SAT. So I just want to find, first of all, where is the position? Which bin does the median fall in? Now, just looking at this, I have a guess that it's probably somewhere probably in one of these two bins here, but I want to find for sure. I don't want to guess. All right, so I'm going to divide by 2, my sample size by 2 to determine the position. So 55 divided by 2 is 27.5. What does that mean? Well, that means that my median is at 27.5. Well, that would mean between the 27th and the 28th data point. So if I just start summing the different bins until I find which interval that falls in. So if I add the first and the second, so 2 plus 3 would be 5, plus another 5 would be 10, 17, here would be 26, so the 27th and a half data value falls in this bin here. So I know that the median is between 24 and 27. As always, please reach out with any questions that you have.